Hi, I'm here today to talk to you a little bit about exploring transformations using matrices and GeoGebra. And we're going to make use of the spreadsheet quite a bit today. So you want to make sure that you have the algebra view, graphics view, and spreadsheet all open. If you don't, you can go underneath the view menu and make sure that you've checked off algebra, spreadsheet, and graphics. Lastly, underneath the options here, go ahead and underneath the labeling option, make sure that only new points are labeled. And with that, we can begin. What I'd like you to do to start off is create a couple of points. We're going to create a point A that equals 1, 0, and B equals the point 0, 1. We're going to use these points to create a identity matrix. So we have our points A and B, and I'd like to define the cell here, cell A1, to be the x-coordinate of this point A. I'd like to define A2, the cell, to be the y-coordinate of point A, and similarly for cells B1 and B2. So go ahead and under the input bar, type in A1. It's going to equal the x-coordinate of A. A2 is going to equal the y-coordinate of A. B1 is going to equal the x-coordinate of B. B2 is going to equal the y-coordinate of B. So once you've entered in those four commands, you should see what appears to be a 2x2 matrix in your spreadsheet. Now GeoGebra doesn't view this as a matrix quite yet. These are just individual cells in the spreadsheet. But if you highlight all of them, as I've done here, and right-click on any of the cells, you can actually create a matrix from these from the cells. So right-click underneath the Create menu item, pick Matrix. You'll notice that there's now a matrix 1 that's been defined in the algebra view. What we're going to do actually is create a pre-image here in the graphics view, multiply its vertices by matrix 1 to create a image transformation of the original pre-image. So let's go ahead and create a triangle here in the graphics view. We first click on graphics and then use the polygon tool to create a triangle. I'm just going to click on 3 points, C, D, and E. And then what I'd like to do now is define points C prime, D prime, and E prime as a product of matrix 1 times the coordinate of each point. So here in the input bar again, this time I'm going to define C prime to equal matrix 1 times C. D prime is going to equal matrix 1 times D. And E prime is going to equal matrix 1 times E. If I move A and B around, you'll notice that E prime, D prime, and C prime are distinct from C, D, and E on the pre-image. So it would be really nice to create a polygon that connects these together. And we'll use the input bar to do that. I'm just going to type polygon and then connect points C prime, D prime, and E prime. I type polygon, then each of the vertices of the polygon separated by commas. Once you've done that, go ahead and hit enter, and that should connect the vertices together. Lastly, I'd like to be able to better visualize the transformational matrix. And so I'm going to define a polygon using points A and B. Type in polygon. We're going to use the origin as our first vertex. A, comma A plus B, comma B. I hit enter. It creates a little unit square here. Now when I drag A and B around, I can begin to make some conjectures about the impact of pre-multiplying by this matrix upon the pre-image. How does this transformational matrix transform our pre-image? And I'm going to close the algebra view. I just really want to focus on the graphics and the matrix as it's displayed over here. I can move this over a tad too. It's good to have lots of room. Now, something that's a little bit interesting to me is taking a moment and measuring the area of each. I'll pick the area tool and click on the pre-image and the image and compare the areas. Notice that these two triangles are not congruent, and yet they have the same area. Furthermore, notice that the product of these two actually equals 1. It's kind of interesting. If I drag point B over further, notice that the area still stays the same. We have a parallelogram here. I don't know if that's important or not. If I drag A up, notice this is still a parallelogram. Now, however, the area of the image is 3 times that of the pre-image. And interestingly, the product here is still, it's -1. This product is 2. Interesting. So we'd just like you to explore this sketch a bit. Be certain to drag points A and B around and observe changes. Make some hypotheses. Make some hypotheses about the shape of this polygon and the impact of the pre-image matrix upon the transformational matrix upon this pre-image. Some things to try. GeoGebra will operate on matrices, so you could create a second matrix down here and explore which operations you can perform on the 2 matrices. We'll talk more about that in future sessions. So have some fun, and we'll talk to you soon.